here we come to the last part of this lecture. Okay, so yeah, after this part, and then you move to the application, and then we will touch the VR, AR, chatbot, and then the wearable device, etc., etc. So you will be more interesting. But right now we have to do something that finish the theoretical part. So yeah, we have to do with the unsupervised learning, the last part. Unsupervised learning can be easily classified into two things. First one is clustering, another is dimension reduction. So unlike the supervised learning, you have collect the sample data with the expected result. But the unsupervised learning, you only have the you only have the sample data. Okay, so just let the machine learning to do all the things for you, to understand all the things to you. And then because it's learned by the machine, and then you do not have any guideline, so yeah, honestly, you cannot guide them to say that, hey, this one is cats, this one is dog, and then this one we can estimate the housing price, etc., etc. You do not have this kind of output. The only output is you just try to help you to divide into different groups. For example, clustering. Clustering is divide you into different groups. Okay, so depends on your input result. So we try to divide you into different groups, and that is called clustering. And then something that is also belongs to unsupervised learning is called dimension deduction. For example, if you have collect lots of the data, and then you want to find which dimension is useful, which dimension that I have collect is totally rubbish, then you use the dimension reduction. So this one is useful. And then for clustering, when you go outside or you go to the research graduate school, so k-mean cluster and other cluster will be the common method. Dimension reduction, so most likely we will have the PCA to find out which data is really important, and then you will learn this kind of technique in SPSS. But honestly, in our class, we cannot touch a lot because talking about clustering or dimension reductions, so you have to deal with lots of data. And this lots of data, if I ask you to do it one by one, or by Excel, or by the other human method, right, to complete, it will be very inhuman. So I will keep this part to your graduate school, and then we will just have the overlook and then understand the basic idea of these two parts. Move to clustering. So yeah, maybe it's a little bit abstract to you, right? Because from our previous example, cats and dogs classifications, and then the result, you have the cats, you have the dogs. It's really easy to understand. And then for the regressions, you have the linear regression, you have the housing price, and then it's all about money. It's all about numeric data that can reflect the real data, real situation. It's really easy to understand. But what is clustering? Yeah, clustering, somehow in your daily life, you can experience lots of the things about the clustering. Try to emerge YouTube, Taobao, HKTV Mall, or the Spotify, or all sorts of this kind of the web platforms, or the app platforms. The landing page of this kind of platform, PS, we call it again, is a platform access surface, PS. So they are using the clustering technique to cluster the customer. So what's the meaning, right? So suppose that I always watch YouTube, and then I watch the Gundam. I always watch Gundam. I watch the game videos. I watch the Cantonese. I watch the news, etc. So when you watch this kind of videos, so you will obtain some label from the YouTube platform. So they will put the label of Gundam, you put the label of ACG, they will put the label of different videos onto your account. So those are your probability. And then in another terms, you have another people that will have different label. For example, she's a mother, and then she always watch the baby videos. She always watch the how to teach a kindergarten children's, etc., etc., child, etc. So they will have lots of the label. Once you have this kind of label, put it into your account. So they will try to use this label to caster the customer. So once they have the have customer into different group, so they knows that what is the next video that should recommend or that should be suggested to you. Similarly to the Spotify, the music, similarly to the Taobao. So HKTV Mall, this kind of the shopping platforms. So they have the your information, they have the data, and it's really important because this kind of data can also easy to measure your behavior with the other. When they have they can measure the behavior of you and the others, so they know that the love, the favorite movie, the favorite songs of the other can also fit you. Because under the big data, here we talk about the big data. Under the big data, when we have lots of the information about the about the user, so we or I and you are almost the same, or at least my behavior can be fall into some similar behavior of the other. So it's a common situation. It's a I would say that is a phenomenon of all of our peoples inside the big data, and that is the clustering into a unsupervised learning. So a unsupervised again is a machine learning type, right? So you have the data set, but the data set without any labels and without any target to predict. That means that just like the customer clustering, right? So you have lots of the customer, you want to form it into different group, but honestly, you will not give a label to a certain group because all the behavior, all their situation may be changed, and then it's really hard to find a label that can represent you. Just like when you're watching the YouTube movie, right? So how to find some wordings to represent you. Yeah, for example, you can put myself as a male, is a adult. But if I'm a male, so sometimes because I'm also a father, so I will also watch some video that is how to teach the children, etc. So it's really hard to find a label or find a classification that can represent a human or human behavior. And with this kind of this situation, we need a unsupervised learning. We only need to find a group, and then this group of people, they have similar behavior, and then we just say that they are in a cluster, they are in a group, and that is the situation. So there are different branch of the supervised learning. Clustering algorithm is one of them. So as I have mentioned to you before, so we have the here K-mean cluster. The algorithm name is called K-mean cluster. K means that how many cluster you want to form. For example, if you want to form 2 cluster, then your K is equal to 2. Okay. So if you want to form a 3 cluster, so your K equals to 3, etc., etc. K is the number of cluster you want to form. So most likely they are based on similarity, and then K-mean cluster is based on the distance to calculate. So it's one of the common, easier method to do the clustering for your group. Then you also have the dimensional deduction. So later on you will learn statistics in another course. So you learn lots of the things that is related to the PCA. So PCA is one of the method that helps you to reduce the dimension because you have the target output. You have one output Y values, right? Y values. But you can collect X many X1, X2, X3 inputs you can. So to save your computer, to save your human power, to save your computation power, etc., you need to reduce the meaningless dimension before you do the linear regression, or you do the classifications. And then the method to do the dimensional deduction is called PCA. Okay, so again, you also learn some keywords in this course to help you to say that, hey, I'm a graduate school student, so I learn a little bit that is not only about your field, also about the other fields, to show that you are a university student, you are you grad student. So the things that we are going to do is find the association root minings and then generate the algorithm, generate something that we can support our unsupervised learning to let the machine to learn all the relationship by themselves. So just like I have mentioned before, lots of the platform, YouTube, TikTok, all the things, they are doing some customer segmentation. They are doing some customer clustering. So based on different values, so perhaps you have the age, you have the website engagement. That means how many times you spend on YouTube or how many times you spend on TikTok every day. Honestly, do you know how to track on your mobile phone, smartphone, how many times you have spent on your YouTube? Yes, right? So when you go to the settings, so you can find the screen time. So when you click the screen time, so there is a statistic about how many hours, how many minutes that you have spent on YouTube or spent on TikTok. So we are almost the same, right? So perhaps when you will share with the others about your screen time, so the top one may be YouTube and TikTok. The second one will be a social media. So maybe is IG or maybe it's Facebook or maybe the others, and then you will be some instant messenger. And again, so will be some shopping apps, etc., etc. Maybe later, and then you have some games. So that is the common pattern, common behavior. So that's why under the big data, we are almost the same. Is this kind of understanding. So we have the age, and then we have the website engagement. Suppose that we only have two-dimensional, and then we want to do the clustering. So we plot the distribution, and then it's easy by looking at the this two-dimensional graph. So you can easily, hey, circle, yeah, one clustering, two clustering, three clustering, because lots of them they are in a small circle, and in the statistic kingdom websites that we will do in the online exercise and face-to-face exercise, you can also observe these kind of situations. Only by the human eyes, you can observe there are 1, 2, 3 cluster similar situations. So we have prepared data for you to do these kind of things. With the clustering, with the segmentations, so we can identify, hey, this one is cluster 1, this one is cluster 2, this one is cluster 3, and then we can define different marketing strategy to different cluster. For example, if here is not very good, but perhaps they are white people, so we can push different video that is related to I don't know, related to BBC or related to the CNN to them. So if they are car people, so perhaps we can put another content to them. And political correct, right? So we cannot say label they are car people or they are the white people, etc. So that's why clustering is really important. And honestly, perhaps by studying their demographic data, you find, hey, most of them are car people, most of them they are white people, but perhaps there is some car people in the strategy. Perhaps they love the American style, they love the American culture, etc., and then they fall into this one. So you have different strategy for different peoples, and then you have different marketing technique. For example, perhaps they love NBA, they love sport, so you put lots of the sport advertisement to them, and that is your strategy. Yeah, we use clustering in different kinds of the situation. For example, here, just like some Asian wordings, right? So definitely different Asian settings, you have no idea. Just like the Western people, when the Western people are looking at our Chinese wording, they also have no idea because it's not about phonics, right? So we use the similar patterns and then cluster them together. And that is one of the things we can use the clustering to solve the academic problem. So application of the clustering, the most important thing is market segmentation. So you use the market segmentations and then based on their demographic data, based on their purchase behavior, because all of them, there are business value behind. So yeah, that's why lots of the people put the money in the market segmentations and they understand what is the strategy I support, what is the strategies that I can apply to different clustering. Video recommendation, Yeah, you know TikTok, right? So yeah, TikTok, YouTube, Facebook, Short, IG, etc. So there is a big market inside the video segmentation. Today, video segmentation, short videos. So usually they take away about the games. So most likely they are the number one screen time in all age. Wherever you are a elderly, you are the 30 something to 50 something, or you are a teenager, even is below 10. So usually the short TikToks, so they're always the number one. And then yeah, you can have lots of different you have the clustering, so you can have the association rules mining, so you can set the rules and assign to the clustering. That means the strategy. So to test which rules is best strategy for your clustering. So yeah, you know YouTube, right? So YouTube, they're always doing this kind of association rules mining together with the clustering, and then push the YouTube videos to your recommendation, at least the landing page, and then the next video that you want to enjoy. Towards the end, so unsupervised learning about the dimension deduction. Dimensional deduction is somehow I collect too many input data, dimension x1, x2, x3, etc. And then throughout the PCA, I find that some of the dimension is useful. For example, I find that x1 is useful here, x2 dimension is useless because they are not affecting the estimate y, okay, the estimate value, estimate output y. So we find that x2 is useless, and then we just skip the x2, just like the housing price estimation. So we put the number of backgrounds, number of bedroom, number of bathroom, etc., etc. We put it together to estimate the pricing of the house. And then we usually find that lots of the informations will be useless. For example, the crime rate or distance to the school is used that we want to estimate something that is related to the neighborhood quality, the quality, living quality, QL of your quality of life, yeah, QL of your living area. So we want to have this kind of data. So that is called dimension deduction. Usually we use the PCA, remember PCA, and then I would say that data analyze 1, 2, 3. So the first one is try to reduce your dimension before you put it into the machine learning algorithm, because garbage in and garbage out. Sometimes the machine learning algorithm is good that they can filter out your useless dimension, but sometimes they cannot. So your useless dimension, they will pollute your accuracy and then pollute your error. More and more. So beside the supervised and unsupervised learning, so there are some small subsets of the machine learning. For example, semi-supervised, and for example, reinforcement learning. Reinforcement learning means that the machine learning algorithm try to use their method to award or punish the correct and incorrect action. For example, the correct action, they will give the award, so they will encourage the machine learning algorithm to repeat and repeat the correct actions. For the incorrect action, they will have the punishment, so they will discourage them to repeat, repeat, and repeat. So by this kind of concept, so your AI or machine learning model can be improved, because correct action, award, incorrect action, punish, and then that is something called reinforcement learning. Reinforcement learning is an agent-based, and then it's based on the actions and then how your action react with the environment. So they will give the mask, and then the mask can they award and then also punish your actions. One of the common well-known AI model will be the DeepMind. Okay, so AlphaGo, right? So AlphaGos, they learn about the goal, and then this goal is using the reinforcement learning. So they punish the incorrect step, and then they give award to the correct step, so that the whole machine learning method, they can improve and improve until right now, around 10 years. They are number one, and still they are always number one. And then we say that, hey, we cannot win the AlphaGo anymore. And right now, at the very beginning, AlphaGo learned the data by humans. So they study lots of the steps from the human. But except remember, around 5 to 6 years ago, AlphaGo start something that totally zero from human. So they use the random step and then learn the correct step one by one, correct reinforcement learning one by one. And finally, right now, our model cannot predict, or our human reasoning cannot predict the AlphaGo situation, because all the steps, they are not from the human, they are from the machine, and then we are hard to understand the reasoning behind the AlphaGo, behind the AI model. And yeah, we right now we cannot, yeah, I would say that we never win the AlphaGo again. Not only about the AlphaGo, so they step into different games. For example, today when you play the Mario, so there is another bunch of the player. They use the Mario I/O, and then they use the machine learning, reinforcement learning to learn the Mario action, whether I should move forward, backward, jump, etc., etc., or fire. Okay, or fire. So they learn this kind of the actions, and then they give award to the correct action. So when they can stay alive for longer or close to the goal, right? Mario, you want to move from the starting point to the goal, right? Close to the goal. It's the mass to calculate the reward. So the corrections move close to the goal, or they can stay longer, will get award. So that's why today you can see some of the YouTube videos, they are playing Mario, that the battlefields is generated by AI, and then for we guys human, we cannot win the battlefield that is generated by AI, but we try to design some AI model to learn by reinforcement learning and then beat the AI battlefield. So now it's the AI versus AI. AI generate the battlefield and the AI generate action, and then they compete with each other. And yeah, that is right now the situations. Okay, so yeah, similar to this one. So when they die, we have the punishment, and then when they can perform the correction, for example, jump, they will have the +1, right? We will have the award for the AI agents, and then they will continue the step. Applications of reinforcement learning, most likely the games. Yeah, we have talked about the AlphaGo. And then lots of the robotics. So today you have the Unity, you have the humanoid robot, right? The humanoid robots learn the situations of the physical environment. And then they are using the reinforcement learning. So they are not using the programmer to hard code or to input the rules one by one. Say that when I see an obstacle, I should move left. When I see an obstacle, I should move right. So they use the reinforcement learning to learn the data from the sensor, and then learn the balance of the motor, etc., etc. So all of them, yeah, is done by reinforcement learning. Yeah, your Tesla, your AlphaGo, your self-driving autopilot. So they are not learning from the expert, learning from the human. They are learning from all the things from reinforcement learning, all the things from zero by sensor data, learn the relationship by the data. So there is no space, or I would say that there's no human involvement inside this kind of reinforcement learning. Okay, so it's interesting, and then I hope that you will enjoy the background about the machine learning. So it's time for you to move to our exercise. So before you move to our exercise, perhaps you can calculate the SSE, right? The sum of the square root estimate error in our previous exercise. You redo it, because when you move to our online exercise and face-to-face exercise, we use the Excel to do it. And perhaps you are not clear about how you perform all the calculation, because you just copy and paste the formula, copy and paste the equations. So to prepare for your final quiz, perhaps you need to pause and then do the exercise and then test the understanding of yourself. and then after you do the exercise on about our slide, and then you can move into our exercise. So yeah, that is our lecture of this week. Keep safe.